Welcome to Slayer Labs Windows and Active Directory Pentesting Primer. This course is fully Windows related and covers the entire pentesting process from enumeration to post-exploitation. This course has been designed for you to follow along with access to the kinetic cyber range at Slayer Labs. Content has also been designed as to trim the fat in order to make the course concise without wasting any of your time. Some areas are covered high level and some we go a little deeper. And since this is a primer, it's not all-encompassing, but we did try to cover the most common and realistic TTPs one would run into during a live pen test or a red team engagement. About 50% of the course covers Windows security topics and TTPs, while the other 50% walks through various targets on the kinetic range in order to demonstrate what we've learned throughout this course, providing the student with hands-on scenarios. In a quick outline of the course as we move forward, in order, we'll be covering common Windows services such as WinRM and SMB, domain enumeration with Bloodhound and other tools, initial exploitation, and then privilege, escalation, and post-exploitation. And once those are complete, we'll go into the more exciting part of the full-phase pen testing scenarios. Getting started, we'll first cover a few common Windows services, their purpose, and how they're accessed. Since this is a Windows-related course, we'll try to stick to Windows services and technologies. So for example, just because SSH isn't covered doesn't mean that it can't be installed or running and used as a potential Windows access vector. Discussed first is Windows Remote Management, or WinRM. From a pen testing standpoint, if enabled, this can be used for credentialed remote access. And from a broad high level, you could say it's similar equivalent to SSH in Linux, but is not as commonly enabled. It can be enabled through group policy domain-wide or locally with admin privileges. And WinRM is a great way to manage remote Windows hosts, especially in a large domain. Common tools that are used for WinRM remote access are PowerShell, and this is known as PS remoting. So if you hear that term, it's basically just using PowerShell to establish a WinRM connection. There's also WinRS.exe. It's a built-in Windows binary you can run from the command line. And in Linux, there's EvoWinRM and crackmap.exec. Then demoing, we'll start with WinRS. Use the TAC-R as the remote machine along with the credentials, and then the command you like to run on the remote machine. Then for PS remoting, we use the enter PS session with the computer name and credentials. And then upon success, will be a remote PowerShell session established. Then the invoke commandlet will execute the command remotely without establishing a full PowerShell session. Then on Kali running EvoWinRM, we provide the target along with the username and password. And then this will establish a remote PowerShell session. And with crackmap.exec, you can check a target or a list of targets if WinRM authentication is successful with the provided credentials. And you can also add the TACX argument to execute a remote command. Next is SMB, or sometimes referred to as CIFS. This is a sharing protocol for files, printers, and other resources between networked machines. A few common shares to note are $C and admin$, which are default hidden administrative shares. These can be accessible remotely if sharing is enabled with admin privileges. And $C typically references the C root directory, and then admin$ references the Windows system folder. Also, a few big name exploits have involved vulnerable implementations of SMB, including SMB Ghost, which affected SMB version 3. There's also MS17010, otherwise known as EternalBlue, which affected SMB version 1. Common tools to access SMB shares and interact with the SMB protocol are SMB client, PSExec. You can use File Explorer, Windows command line, crack map exec, and then there's a variety of in-packet tools. At first, we can use psexec on a Windows system, and here it's just going to spawn a new shell, command line shell, to the remote host demo as user eve. And next, psexec again, and we're going to use the S flag to spawn a new session as system. And here we'll use the netuse command, and we're going to map a drive W to the remote share demo / share, providing the username and password. And as you can see here, the W drive exists and it maps to the new share. And here on Kali, we can use crack map exec with SMB providing the remote host along with username and password, which is both Eve. And then when it says pwned, that basically means that user can access the admin shares like $, admin $. Next, we can use SMB client with user Eve, and then we're going to escape the backslashes, and we're just going to try to get to $. In-packet also has a version of SMB client, just provided the username, remote host, and password. We can also use in-packet's SMB exec. We provided the username and the remote host along with the password. And this functions similar to psexec, but it is a little more, it's listed here. It's semi-interactive, so you have to be careful what you execute. In-packet also has their version of psexec, just provided the username along with the password and remote host. And this, by default, will spawn a system shell, which is similar to the TAC S flag in the native psexec. Windows Management Instrumentation, or WMI, is a critical built-in feature within the Windows operating system. Typically, it can be accessed locally from the command line or PowerShell in order to enumerate local resources. WMI can provide you with a ton of data about the target system, from hardware resources to installed applications. If enabled, it can be accessed remotely with local admin privileges. This WMI remote access typically isn't enabled by default, and will also need a Windows Transport Layer technology enabled and configured with WMI, such as WinRM or DCOM. Common tools used to interact with WMI are wimic.exe, which is a built-in Windows binary, PowerShell, along with the in-packet tool WMI exec. Now, demoing on Windows, we can use wimic, and this command will just get the host name of the target. And then in PowerShell, use the get WMI object, and we're going to provide it the remote target along with the WMI class and property we want to pull from the remote target. And then here on Kali, there's in-packet's WMI exec, which with the default arguments will just establish a semi-interactive remote shell. In relation to Windows, Kerberos is a network authentication protocol that's used to authenticate users and services in Windows domain environments. If you're unfamiliar with Kerberos and its relation to Windows, there are plenty of resources available that dive deep into its functionality and go into the weeds. But here we'll just run through a quick high-level overview. In Active Directory in Windows environments, Kerberos is used extensively for authentication between domain-joined systems. When a user logs into a domain-joined box, the system sends a Kerberos request to the KDC, the Key Distribution Center, aka Domain Controller, to obtain a ticket granting ticket, otherwise known as a TGT. This TGT is then used to authenticate the user to other systems on the domain without requiring the user to enter their credentials. Here's a straightforward depiction of the process. So a user requests a TGT from the domain controller. The DC responds with the TGT. The user then requests access to service A from the DC. The DC responds with the TGS to service A if that user has authorization to access service A. The user then authenticates with service A. So the big note here is the user, they're never sending their password to the server which service A is hosted on. So that authentication to service A is done completely with tickets and interaction with that user to the KDC or the domain controller. This technology can be exploited in the form of passive ticket attacks, forging golden tickets, Kerberoasting, ASREP roasting, and more. Common tools to abuse Kerberos are Rubius, Mimikatz, and a slew of impacted tools. And we'll be running through these tools, not now, but actually later in the lab. Starting off with domain enumeration, we'll cover Bloodhound. If you're unfamiliar with Bloodhound, it's a graphical attack path management tool that maps and quantifies Active Directory attack paths. So this helps ultimately giving the attacker a visual representation of the domain and potential attack paths. From a high level on how Bloodhound works, it uses SharpHound as an ingester to collect targeted domain data. Once SharpHound has collected that data, you move the data to a machine which Bloodhound has installed. This could be any machine offline, off domain, or just a box the attacker has control of and can install Bloodhound on. The most common method of collection is just simply running SharpHound, exe or PowerShell script on a domain join target, running as domain join user, and you can just simply run it without any flags. Once ran and completed, it actually drops a zip file on disk, which you can save or which you can exfil and upload back to your machine running Bloodhound. Here we have the data uploaded and imported. You can start by running the pre-built analytics queries. And first running the find all domain admins. Shows here, it turns up an interesting path. As you can see, there are multiple domain users that are members of custom security groups, which those groups are members of the domain admins group. Another option is to search for specific domain objects, then drill down and find its relationships. In this case, we see the kinetic domain users group, which basically includes all domain users. All right, and then clicking domain user group shows the node information. We can kind of drill down, and here we're clicking on sibling objects in the same OU. We see part of the group is part of the research organizational unit, and we see a few other users. And here's the space research, which is the parent OU. Clicking that, we can kind of drill down and kind of shows the users in its nested OUs. You can see GPOs affecting that OU. Here we can see there's multiple GPOs that seem to be non-default. Another feature of Bloodhound is finding the shortest path from A to B. And here we have user Freya and DC0. That user Freya is from before. We know that that user is a member of Covert Crew Group, which is also a member of Data Collectors, which is a member of the domain admins. So you can see here that path laid out all the way to the DC0. In Bloodhound, you also have the option to do raw queries. The query language is Cypher. And in this first example, we'll just search all users that do not require pre-authentication. And we see two users here. So these two users could be ASRIP roasted since they do not require Kerberos pre-authentication. Here's our next example for raw queries. This will be a simple search. It's just going to search all GPOs. You can see a few here that are non-default. We can kind of click this one, always install elevated, to drill down. We can see the directly affected OUs. Clicking the legacy objects OU, we can drill down even further and see the users that are part of this OU. So the idea is that GPO will apply policy to these users. And we see two users, one is Marv and one is Aspen. So noting user Marv is ASRIP roastable and has that always install elevated GPO apply to his user. One attack path would be to ultimately collect his password from the Kerberos pre-authentication vulnerability or ASRIP roast. Then gain access to any computer within that OU. And the OU is legacy objects. Any computer or any object within that OU legacy objects has the always install elevated applied to it, if that makes sense. Then once we get access to one of those machines, one of those computers with Marv's creds, then from there we can escalate privileges via the always install elevated method. And we'll talk about this method along with going through this whole process from roasting, cracking, and escalating privileges in their respective sections. PowerView is a tool specifically designed for Windows domain enumeration. It's written in PowerShell and part of the PowerSploit project under the Recon module. The PowerSploit project is relatively out of date now and will be caught by most antiviruses. There are, however, ports of PowerView, such as SharpView. It's a C# implementation of it that may help to bypass any security. Also tools such as Bloodhound that actually use a modified version of PowerView for data collection. To start using PowerView, you can just download or copy-paste the PowerView PowerShell script and import it as a PowerShell module. And once that's set, you can start running commands. Note this should be done on a domain joined machine and as a domain joined user, as without having domain credentials, you typically shouldn't be able to enumerate domain-related resources, since many of those searches and queries are authenticating and hitting the domain controller. If you have a session in a system or local admin that's not a domain user, you can provide separate credentials on the command line if needed. Here, starting off, we're RDP'd into a domain-joined box with a PowerShell session, and we import PowerView. We'll run through a few basic command lists to illustrate what PowerView can do. This first one here will pull back basic domain information, including the DC's hostname. And this one pulls back all domain groups while selecting only a few properties. Here we can see, starting at the bottom, are the non-default groups. And this next one gets domain trust information. As you can see, there's a bidirectional trust between Kinetic and Spire. And here, PowerView collects all objects with a SPN or service principal name. This can be used to collect users that can potentially be Kerberoasted. Here we see super.svc has SPN as well as that Kerberoasting, which is a built-in account which always has a SPN. More on this in the Kerberoasting section later on. And we can also search for users that don't have Kerberos pre-authentication enabled. And as shown before, we see the user Marv as well as the user Sin. And going through more examples, we can search for all domain users. Then we can narrow it down into more details by individual users. In this case, case. Can also show all domain groups in which an individual user object is associated with. And this one will list all group policy objects, or GPOs. And we can narrow it down by selecting an individual GPO. Also, with the tag v argument, PowerView will print out verbose results, including the actual LDAP searches, which can be useful for raw searches with tools such as dsquery or a Linux LDAP search. LDAP search is a Linux-based tool which can connect, bind, and search an LDAP server. So since Active Directory uses LDAP, we can utilize this tool directly from Kali, as long as we have valid domain credentials and know at least the DC's IP address. This first command will search the known domain controller, then use X to use simple authentication, and then tag S to set the scope to base, which will be giving us the naming contexts of base DNs, which we run on our credentialed searches. So we'll search the entire domain by using this selected naming context of DC Kinetic, DC Corp. And this command will set the base DN as DC Kinetic, DC Corp. We'll set the username as glorp. It's the user that'll be authenticating to the DC, and then tag W is the password. When this search completes, you can see it pulls back a ton of data, and it's basically all the data it can with that user's creds from the LDAP server, aka the domain controller. This example has no filter and just dumps pretty much everything, everything that glorp can access from the domain controller. This next one will be adding a filter which searches all computer objects, setting the object class to computer. And this is like before, except it's only going to pull back computer objects. We can see it pulls back a ton of data for each computer, including some useful information like the OS version, the OS and the OS version. Here, Windows 7 Service Pack 1. Instead of computers, you can also search user objects. This gives us the user object along with the OU and nested OUs they're in. Can search groups as well. In this one, you can see what OU and nested OUs that group is in. As well, it's pretty useful as you can see the users that are members of that group. And here again, we're going to run the same command from before, no filters, bring it back at everything, and we can actually output that to a local file. which this can be useful because you can grep and search through it offline without sending any LDAP traffic. dsquery is a Windows binary in which you can run LDAP searches within a Windows domain. And it's part of the Windows RSAT, or Remote Server Administration Tools. And from a pen testing standpoint, RSAT may be installed on a target system. Otherwise, dsquery, the binary, the exe, can be dropped or moved over manually without triggering generic antivirus. And demoing a few examples, here you can search all computers. And you can search all users, all OUs, searching all groups. You can also use wildcards to search specific strings. And you can add filters. And in this example, we'll search domain trusts. Before we get started in the exploitation process, we'll quickly touch on antivirus and its prevalence within this lab. The kinetic range, along with this course, is designed specifically for Windows pentesting. The goal is to walk through the entire pentesting process, going through the motions, touching on a broad range of Windows security tactics, techniques, and procedures. And with that being said, some targets may have Defender completely disabled, certain features disabled. Defender may be outdated or may be updated and fully enabled. So the ultimate idea is to allow you to get hands-on experience running through these Windows TTPs without continually running into AV or EDR roadblocks. If you run an engagement with updated AV and EDR in place, with a SOC and other advanced security mechanisms in place, then some techniques in this course may need to be obfuscated or altered in order to avoid detection. Low-level AMSI or advanced EDR bypassing isn't within the scope of this course. However, we'll quickly run through some techniques on how to check Defender status, disable features, and avoid detection. Here we have a PS session with a user that has admin privileges, and we'll run get MP computer status to print out the status of Defender and all its features. It shows the product version, engine version, when it was last updated, and probably most importantly, if real-time protection is enabled. If we disable real-time protection, we can run a lot of nasty things. In quarantine binaries such as Mimikatz, Meterpreter, Rubius, or any other well-known red teaming tools. Although just because real-time protection is disabled doesn't mean that there's other antivirus running on the system which would quarantine or catch, flag any malicious content dropped on disk or in memory. And typically, even just to check the status of Defender, such as this command, you'll need admin privileges. One method to avoid detection is use LOL bins or living off the land binary scripts and libraries. You can check out the LOL BAS project. You can check out their GitHub pages. It'll list a ton of binaries which you can execute, download, upload, copy, bypass UAC, and basically just get what you want and need during an engagement, and likely without triggering antivirus. There's also sysinternals, or generally any signed Microsoft binary. There's a few binaries of interest in sysinternals is psexec, which we talked about earlier, along with procdump, which you can basically dump the memory of any running process. Even installing OpenSSH or WinRM on a target will help you get back on with credential access to complete any post-exploitation tasks. This section will broadly focus on initial exploitation techniques for Windows environments. The vast majority of exploitation content will be in the post-exploitation and the full-phased pentesting sections later on. And most examples here will require at least a valid domain user's credentials, and which, if you're following along, will obtain in the first part of Kerberoasting. As-rep roasting is when a user has pre-authentication disabled, which then an attacker can request a valid TGT for that user and crack offline to obtain their password. Pre-authentication is the first step in Kerberos authentication, which is enabled by default for domain users and Active Directory. So one question may be, why would a user have pre-authentication disabled? Mainly for legacy or third-party systems that do not support Kerberos pre-authentication functionality. And then enabling or disabling pre-auth can be done in AD users and computers. This figure depicts the standard process with pre-authentication enabled. Shown here, the user sends the DC an authentication request, which contains client identifiable information that the DC will later decrypt to verify. It's encrypted using a key which is generated by encrypting a timestamp and the user's password hash, which is also done on client side. So the KDC and the user are the only ones that know the password hash. So once it arrives to the KDC, it's decrypted with the password and runs through the verification process. And if it's successful, it responds or sends an AS rep to the client, which they'll need their password to decrypt. Again, normal process with pre-auth enabled, which is default for all domain users. With pre-auth disabled, that whole verification process the KDC does is skipped. The AS rep is sent back to the client who originally requested the TGT, then can be cracked offline to get the user's password. So to get started, AS rep roasting, we'll either need valid domain user credentials or we'll need a list of domain users to test to see if they have pre-authentication disabled. And here on target corpo, there's a list of usernames to give as a hint. Dennis, Sin, and Ward. So our plan of attack will be to check if any of these users have pre-authentication disabled. Using Impackets tools, there's a get np users Python script, which you can use to check a list of users or an entire domain or individual users to see if they have pre-authentication disabled. Here, since we have those three usernames, we'll start with Dennis and include the domain's IP address along with outputting that potential hash in the John format. And here Dennis does not have pre-authentication disabled. Now we'll try Sin. And we see that user does have pre-authentication disabled. So we'll copy that hash and put it in a separate file. And then we'll try the last user, Ward. And that user does not have pre-authentication disabled. The next part is pretty straightforward. Just run John the Ripper, providing it the hash and the word list. And in this range, to keep it pretty straightforward for the attacker, only Rocky or John are used as password lists. And you can provide it the hash type, otherwise leave it blank, and John's pretty good about figuring it out. And here shown, you can see the cracking was successful. The Kerberoasting process involves identifying an AD object with a service principal name set, otherwise known as a SPN. This will then allow you to request a TGS from that account. Setting an SPN essentially makes it a service account, allowing a valid domain user to request that TGS. Then once that TGS is collected, attempt to crack it offline to obtain the service account password. In order to identify an AD object that has an SPN set, you can use a variety of tools as discussed in the previous section, the Kerberos section. And here in this scenario, we'll use a Metasploit module along with John the Ripper. Using the Metasploit module get users SPNs is pretty straightforward. Just provide the DC as the rhost, provide the valid domain user credentials, and run it. And here we get one user account, super.svc. Copy that hash, paste into a file, and then we'll run John. It's worth noting if the service account is set up properly as a managed service account, the password would be very strong and updated regularly. So this would make it very difficult to actually crack this hash. And after John the Ripper is complete, we show a valid password. We'll run through exploiting MS17010 or EternalBlue. This is an older vulnerability and will likely be patched in a real-world scenario. We'll go through the identification and exploitation process anyways, since SMB has had many critical vulnerabilities throughout its history. Plus, this will be a good introductory example of running Metasploit, including an auxiliary module to identify vulnerable targets and the exploitation module to get a reverse shell. First, we'll set up the Metasploit auxiliary module. And the goal of this will be to scan a list of targets to see if they're vulnerable to MS17010. We'll set the rhost to a file that contains a list of IPs within the kinetic range. Then we'll run it. Once the scan is complete, we'll set up the exploitation module, since we saw one target appear to be vulnerable. And here we just set up the listener, which will use a interpreter reverse TCP shell. Then we'll set the target. And then we'll run it. And the exploit completed successfully, getting a valid interpreter session. Password spraying is a useful technique if you have a list of valid domain users along with a lax domain password policy. You can use a list of known users with a list of weak passwords to attempt to authenticate with various open services, such as SMB, WinRM, SSH, or RDP. Here's a scan target with open services of SSH, SMB, and RDP. So in order to get a list of users, there is a share that allows anonymous login on this server that was scanned. And on that share are a few notes, including potential usernames. And a hint that the password policy is lax, including no account lockout and complex passwords disabled. So with the names in the incident report, we'll create a user list of the 4 users that were listed. This target is on another domain from which we've obtained credentials for. So we do not have any credentials to this domain, but if you did, you could use poll enum, and that's hitting the kinetic domain controller. And what this tool does, it brings back the domain password policy. You can also search password policy with LDAP search. You will need the base name that you want to search, along with valid domain credentials. And again, this example is hitting the kinetic domain, which is not the target of the one we want to password spray. This is just showing that you can get the password policy if you have valid domain user credentials. And in the output shows the threshold the same and the lockout window, which is in seconds, 300 seconds, 5 minutes. Now, since there are multiple services running, we'll divide up the user list into 2 each. And then our plan of attack will be to spray each list against different services. Here using Hydra, we'll use the first list with John, and uplink is the host name, and the protocol we're going to spray is SSH. And then we'll use crack map exec against the SMB protocol, uplink host name, and then we'll use it against that second user list using John password list as well. Also note these methods are more along the lines of brute forcing versus password spraying. If we did want a password spray, we could just use that list, the user list, along with just one password, and that way that one password would iterate through the list of users versus trying many passwords with only a handful of users. And once Hydra is complete, we did crack both users in the list, as well as one user with CME. You can also use the built-in Kali tool spray, and this will set the protocol, hostname, user list, and password list, along with the account logout threshold and time. So this would be after 10 password attempts per user, it will pause for 5 minutes and then run through it again, 10 attempts each user, pause for 5 minutes, and continue. This is probably more of a password spraying-esque tool versus brute forcing using just a user list and password list. This would actually account for the password policy if one actually existed. And here in this demo, there really is no password policy for the host we're targeting. This exercise will run a authenticated remote code execution against SharePoint Server 2019. The target will be the Belfry, and we'll use the credentials from earlier, ASRepRoasting, SYN IceMagic 9, and the path sites/operations, if you're following along in the lab, can be obtained from another target. And since we're logging in remotely from a non-domain joined machine, it can be kind of finicky logging in, depending on the browser, if you need to provide the domain or not the domain. After logging in, we can check the help menu to see what version of SharePoint is running. You can also check to see if building version.cnf is exposed. And here it's shown, and we can Google that to see the exact version information. And then after doing some research on potential exploits for SharePoint with that version, along with there's a hint in the kinetic range that you may run into. This hint will provide the CVE ID, along with a link to the write-up, including the proof of concept. The prereqs we'll need for this exploit are the proof of concept. This is on the ZDI page. A Windows machine with Visual Studio installed. This is in order to compile and tweak our exploit. Otherwise, an alternative to Visual Studio can be used. We'll also need whysoserial.net installed. Also a valid domain user, and which we have from before, SYN IceMagic 9, along with a share that can be accessible to anyone, including anonymous users or non-domain join users. And we already have access to one of these shares in the range with host uplink, as we saw earlier from the password spraying scenario. And we'll also need credentialed access to a domain join machine. Since this is a code execution exploit, we'll first test to see if we can download a remote text file and write it to a publicly accessible web path. This method will be a little more stealth than dropping a interpreter binary to disk and executing blindly, hoping to catch a reverse shell. As noted from earlier, the VTI PVT path is accessible, so that will be our target path to write the downloaded file to. We'll also try our luck with the common default SharePoint local path, including that VTI PVT directory. As shown here in the ysoserial command, we'll download s.text from our target server and then write it as a.text to the full web path. And again, that full web path, we don't know. The C, inap hub, www.root, WSS, etc. It's just a common default path for SharePoint, but this may not work in all scenarios. For example, it could be an e/mywebapp/SharePoint/2019. And since it's code execution with really no response, it's sort of blind. We're executing code on the system without getting an output. We really wouldn't know that full path, that full web directory public path, unless we were able to somehow get the output from the command execution. This can be done in other various ways, but right now we're not going to go into it. From the ZDI write-up, we need to open the resx file, and then we'll paste the output from the ysoserial command in here. We'll paste the output in this file, and then we'll save it. And then we can run to Visual Studio and build the solution. And the solution relies on that resx file, so every time you update the payload, you have to recompile, and which actually produces this resources file. Then with that resources file, we'll paste into uplink share that has anonymous login, basically allows anybody to access the share, access that file, which is a requirement for the exploit. In here we have a SSH session with Polar, since another requirement is running this exploit proof of concept on a domain join machine. And here are all the correct parameters. The proof of concept is sp2.exe. We provide the Belfry IP address, 1065.134, sites operations. We provide that full URL along with the domain credentials, domain, and then the UNC, the file share path to the resources file. Also a note for this exploit: if you change the ysoserial code execution payload, then recompile, you only need to replace the resource file on that share and not the actual compiled exe binary. So once that initial compiled exe is on a domain join target, this sp2.exe, so once that's moved over, there's no need to move over any new copies if that payload's changed and recompiled. Just the resources file needs to be moved over. And even though it shows an error, it may still work. As we see, it does appear it works. The contents of a.text was Slayer Labs, as seen. Now, since we know we can write to a public web directory, we'll basically go through the same process, but instead of dropping a text file, we'll drop a ASPX web shell. Running the ysoserial command, we'll do the same thing. Copy the output, and then we'll paste into that resx file, replacing all the content from our last run. Replace, save, and then we'll recompile again. And then we'll copy paste our new resource file, drop it on that share. go back to our SSH session on Polar, the domain join box, and then we'll run that proof of concept, providing it the resource file, the new one, the updated one. And now we can check that path at cmd.aspx in that VTI PVT directory. And it looks to be successful. In this example, we use WebDAV to upload a web shell to get initial code execution. Then from there, upload a more stable interpreter shell. WebDAV is a web authoring service which allows admins to upload files to a remote server over HTTP or HTTPS. Similar to FTP, but over the web over HTTP, and targeted for web-based applications. Also, a side note, like a few other examples in this initial exploitation section, this one isn't technically full initial access, since this scenario, like others, will also require proper credentials. And these credentials were obtained in the ASREP roasting example, which is the user SYN, CYN, and the password IceMagic9. Here's an Nmap scan showing port 80 and the /dav URL to be hosting the WebDAV service. So with knowledge that the server is running WebDAV, we use DavTest, which is built into Kali, providing the full domain user, password, and the URL. And what DavTest will do, we'll upload a bunch of random files with various extensions. You'll upload them, and then it will try to execute them. The goal of seeing what can be dropped and what can be executed. In this example, the extensions of interest are ASP and ASPX. Since it's a server-side language and we're obviously running on a Windows target. So the goal will be to move a ASPX web shell to our working directory, and then we'll upload that web shell to the target server and see if it works. We can upload the file using DavTest, providing it the previous credentials, target URL, use the upload files and the upload destination flags, and it'll just be cmd.asp.aspx. We have the URL to check if the upload was successful. We have to provide the credentials if we're going through the web browser. And here we have a valid web shell running a few commands. From here we can upload a more stable shell. We'll use Meterpreter. And we'll build that out with MSF Venom. Set the payload, localhost, local port 4444, and we'll set it as an exe. Then we'll get our listener started, opening Metasploit, and set up the listener properly, listening on 4444. Then we'll use DavTest again to upload the exe, and it'll be corpo.exe on the target. Now, as noted before, we'll run into an issue here since DavTest did not test exes, so it was not able to execute that exe from the web browser. As you can see, it's just downloading the exe when we navigate to that URL. So the plan here will be to utilize our already established ASPX web shell, and corpo.exe is already on the target, so we're just going to run a command to execute corpo.exe from the web shell, since we have obvious command execution on the target. And now we just have to figure out specifically where the corpo.exe was dropped. And typically the IIS web root is C inaphub www root. So we can check that, and we see the DAV directory as well. So we'll go into DAV, and we are able to see corpo.exe. So from here, we're going to use cmd.exe with a /c flag, which will execute a command. And in this case, it's just going to be the full path to corpo.exe now that we have it. We'll execute it, and we get a valid interpreter shell. NTLM relay attacks involve the attacker intercepting network NTLM authentication requests from legitimate users and then relay those, or you can crack them offline, to further gain access to domain resources. This attack can be done without any existing credentials or access by the attacker, which makes it a common technique in live red team engagements. And here in the kinetic range, there are just a few simulated users, so not even close to what a corporate environment would look like. Also, since some of the processes in NTLM relay attacks require man in the middle and poisoning certain network traffic, this may lead to negative effects on the entire domain's functionality. Testing and learning the entirety of NTLM relay attacks is probably best to have a full access to your own small lab setup. This way you can access all the machines, mimic users, and if you break the domain's functionality, it won't affect other users, especially in a live production environment or a range here on Slayer Labs. We will, however, cover a few practical methods that aren't super intrusive. First off, net NTLM, aka NTLM v1 or NTLM v2, is different than NTLM. They are hashes used in the challenge response process when authenticating to Windows network resources. NTLM v2 is the standard nowadays, and as a note, it's much more resource intensive to crack than the NTLM hash. Also note you cannot pass the hash with net NTLM, but you can with NTLM, and more on pass the hash in a later section. So to fully set up and successfully execute an NTLM relay attack, the LLMNR protocol must be enabled on the domain, which is by default. Also, SMB signing on the target host must be disabled, which is disabled on most Windows versions by default, mainly Windows 10. And you have to be on the same broadcasting domain, same subnet, which Slayer Labs we will not be because we're VPN'd in and we're on a specific subnet. We can, however, still showcase a few relay-related attack methods. First, a simple example to collect a user's net NTLM hash. You can set up Impagut's SMB server script running on your Kali machine. Then, for example, say you have a reverse shell on a target, which you're running under a user account with low privilege access, where you don't have the password and you can't escalate privileges. This technique you can connect to your Kali SMB server, and it'll collect the net NTLM hash. And off screen, we just made a connection with the user CRAM back to our Kali SMB server. And with that, you can try to crack offline if the password's relatively weak. It's not ideal, but it illustrates the net NTLM collection method. Responder is also a key tool for complete NTLM relay attacks. Here's just listening on the VPN interface with SMB and other services shown as listening. And if we were on the same broadcast network as kinetic domains, we'd be seeing a lot of broadcast traffic. Then in turn, we could roll through that entire relay attack process. And just like the SMB server example, if a victim tried to connect to our IP using SMB or any of the services listed, their net NTLM hash would be shown. And off screen, we connected with user CRAM, but it's already been collected and saved, which is why it's not logging. Then a bogus user admin.super is used to connect as a live example. Next is InPacket's NTLM relay X. Here, in addition to what the other tools did, every time a net NTLM hash is collected, the tool will relay and try to authenticate with that hash against a list of hosts. And shown as a list of targets with SMB signing disabled, which can be automated with CME. And a quick note to clear up any confusion, the list in the InPacket script command is smaller for the sake of brevity. Now, if the authentication is successful on any of the hosts in the list, that means that user we collected the net NTLM hash from, that means they're local admin on the specific target, or they have local admin privileges on that specific target. Also, quick note, this error here in InPacket, we have our Apache web server running. This is why it's throwing that error, port 80. So we can disregard. And by default, this tool will then, on successful SMB authentication, will automatically dump the SAM database's NTLM hashes. This can then be used to further pass the hash or crack NTLM offline more efficiently. Again, more on NTLM and pass the hash in later sections. This section will touch on a few tools and methods for local Windows privilege escalation, from the perspective as if you had low privileged access to a Windows machine and you wanted to gain local admin or system level privileges. Specifically, the scope will be local versus domain escalation. Since there are an exhausting amount of Windows PrivEsc methods, we won't cover all of them. We'll go through a few tools and methods here, then later in the full-phase pen testing section, more will be covered as practical scenarios. A few common Windows PrivEsc methods are stored credentials, unquoted service paths, vulnerable Windows services, and always install elevated. Again, there are many, many more, but these are a handful of the most prevalent. The tool WinPs, or Windows Privilege Escalation Awesome Script, will run checks for most all of these listed, including many more. It's very verbose and can almost be overwhelming, but provides most all information necessary for local Windows privilege escalation. There are other tools like Seatbelt or JAWS, which run through similar checks along with Windows Exploitation Suggester NG, which checks a target's installed hotfixes or the KBs and then compares them with the database of known vulnerabilities. Note there are additional well-known tools like Watson or PowerUp, to name a few. These are a bit outdated nowadays, which we will not cover in this module. Stored credentials can be any installed application that has credentials stored and reversible, or any other generic file or object with passwords stored in them. A few examples are third-party apps that have config files with the passwords in them, saved text documents with plain text passwords, or emails with passwords or other credentials. This example, we have an RDP session along with a Metasploit multi-handler session established. And the RDP session shows Heidi SQL as an installed application. Heidi SQL is a Windows client to connect to and manage databases. Metasploit actually has a post module which will collect credentials, if any are stored, in a saved session. And using this module, we just set the session to 1. And we simply run it. And after it completes, it shows a valid username and password. Unquoted service path vulnerabilities occur when a service is misconfigured by referencing its service binary without being wrapped in quotes along with having a space somewhere in that full path. This would allow an attacker to implement a malicious binary where the space occurs due to how Windows create process function is designed. So in this example, if the referenced binary for that service was not wrapped in quotes, as we see here, an attacker could implant a malicious binary where that space occurs. So if they dropped it in that location, named my.exe, and then the service was restarted or the system was rebooted in order to just trigger that service to start again, then that my.exe would be executed instead of the service.exe. This method may be somewhat tricky during a pen test because you'll need proper permissions to restart that service. Otherwise, you'll need to reboot the system or have permissions to reboot the system. And the implanted binary will be executed by the service. So if that service is set up to run as a non-admin user, then your binary will be executed with those non-admin privileges. Another common Windows privesc technique is exploiting vulnerable Windows services like SMB or exploiting known kernel bugs. Windows Exploit Suggester, NG, is a tool designed specifically to enumerate system info for these types of vulnerabilities. Running WSNG is pretty simple. You just feed it the output of system info that was collected on your target Windows system. This can be collected, then moved offline to a machine with WSNG installed. This example will only show the vulnerabilities with a severity of critical, and then the TAC-C is to show color. And then this example will show only vulnerabilities with known public exploits with that TAC-E. Always install elevated is a group policy object that allows a non-elevated user to install an MSI package as an elevated user. To install software in Windows, you'll, in most cases, need admin privileges. This allows any user to install an MSI without the need for an admin to install it themselves. Here we'll create an MSI payload with MSF Venom as a reverse shell, and shown it has been moved over to our target we're RDP'd into. And then quickly shown here, trying to run CMD as admin prompts for admin creds, which we do not have. Then when we run the MSI, we get a reverse shell as system. We'll quick touch on a few techniques on how to transfer files from Windows to Kali or vice versa in a simple, straightforward way. Transferring files can be sometimes tricky depending on what sort of access or shell, login type, or firewalls exist on the target system. And first we'll cover downloading via PowerShell. Common method is to use invoke web request along with providing the source UI and the local destination where you'd like to save it. I'm here we're hosting evil.bat and saving to program data evil.bat. You can also use the shorthand, which is IWR or wget, which both use the same invoke web request commandlet. There's also the invoke rest method, along with its shorthand of IRM. Next, SCP can be used to upload or download files. It's built in on newer versions of Windows, but is not on older versions. SCP uses SSH protocol to copy files and send files. So whatever server you're sending the files to will need to be running SSH server. So example, you're on a Windows box with SCP client and you want to upload or move target Windows files back to your Kali server, then just make sure SSH service is running on Kali in order for those uploads to work. And here we're uploading juice.txt from Windows to our Kali machine with user Kali, which will save to our temp directory. Now, if SSH is enabled on a Windows target, you can download from that Windows target to Kali. Like here, you're moving a target file juice with user cram at polar, and we'll save that to our temp directory as juice2.txt. And again, if the Windows target has SSH enabled, we can upload as well. Copying local file from Kali, WinPs, over to polar with crams creds, sending to the program data directory. Bitsadmin is a built-in Windows binary, which can also download remote files. It can be wonky depending on what type of shell or session you have. Shown here, it doesn't work while we're SSH'd. Then if we're RDP'd, it does work. There's also a certutil, which is a built-in binary to download remote files. Note that Defender will sometimes catch and flag this as malware, blocking any download attempts. With certutil, you can also encode and decode using base64, which may help if you have the ability to copy-paste from your terminal to transfer binaries or unique files to avoid any mangling. Example such as encoding an exe file as base64 from Kali, then copy-pasting that output to target via terminal or like an established shell, and then decoding that base64 on Windows to an exe using certutil. Setting up a temporary SMB share on your Kali machine with Impact as SMB server is also a useful technique. Newer versions of Windows may require SMB support along with a username and password. Shown here are the creds with the share name of Kali, which will be hosted out of our temp directory. Now on the target Windows machine with the SSH established session, we'll have to use the net use command to map that Kali share to a drive. And here we're mapping to the X drive. This can be arbitrary, whatever's available on the Windows host. Onto our setup with the share credentials we added. And once that's mapped, you can access the X drive here or our temp directory. And a quick note on local account token filter policy, which is a non-default registry key. When flipped to 1, will allow local members of the administrators group remote access with a high integrity token. So without this enabled, any local user that is part of the administrators group, besides that built-in administrator or the otherwise known as the RID 500 administrator, will not be able to run remote operations unless they use RDP or like a similar service. So for example, on the demo target, using Eve's credentials, which is a local administrator but not that RID 500 built-in administrator. Running psexec or remote commands through WMI as this user Eve will fail. Then using the built-in administrator or the RID 500 user, psexec is successful. If you are, however, a domain user with local admin privileges, then this filter will not affect you. You'll be able to execute commands with high integrity tokens. Now flipping that registry key to 1, we can try to psexec with Eve again. And we see it is successful. Also running administrator again, we see it is successful, as it is the RAID 500 built-in administrator. It should be successful, should be able to run remote commands with higher integrity token, such as psexec. If that key exists, or if it does, if it's flipped to 1 to 0, it should stay the same for this built-in administrator. Testing on a domain join target, femme fatale, having this register key non-existent in its default state. We're authenticating with domain creds as Freya, who has local admin privileges, but again is a domain user. We get a successful psexec response. Once you've gained admin level privileges on a target, collecting Windows user credentials may assist you in pivoting or moving laterally. Specifically in this section, we'll talk about local and domain users. Local users, or users that are not domain users, have their passwords stored in NTLM hashes, and domain users have their passwords stored in MS cache if they've logged into that specific Windows host. Both of these hashes require local admin privileges, and it would typically be tough to crack if there was a strong, fine-grained password policy in place. If the attacker has the time and resources, though, these can eventually be cracked. A short password age may be one way to mitigate this vector. However, in Kinetic Labs, password policies are lax in order to allow the attacker to learn these password collection and cracking techniques. NTLM has a format divided into 2 parts. The first part is outdated and will rarely, if ever, be used in a real engagement, which is the LM portion, and still exists for legacy purposes. And the second portion is the NT, which we'll focus on. This is the portion we'll feed into Hashcat or John the Ripper. It's still called NTLM, even though the LM isn't really used. MS cache, or domain cached credentials, are passwords of domain join users that have logged into specific Windows targets. Since these users authenticate with a remote domain controller, the MS cache is set to allow users to still log in if they're offline or on a different network, or basically any place and where they can't reach that DC to authenticate. Example, if you were given a sales presentation at a client's office and you have your PowerPoint, your docs, spreadsheets all on your work laptop ready to present, you arrive, hook up your audio video devices, and realize you can't log into your laptop. This is the reason for MS cache, which this is enabled by default. This can, however, be disabled in group policy. Starting off, we'll run Impacket's secrets dump from Kali remotely, which is probably the simplest method to get NTLM and MS cached credentials if you have the proper credentials. Once complete, it shows the hashes of local user Ivory and domain users of Cram and another user Wang. So again, this means Ivory is a local user to that specific machine, while Wang and Cram are domain users who've authenticated with that DC and logged into this machine at least once. Next, running through a few NTLM collection methods is the Metasploit post module of smart hash dump. And we just set the session of an already established shell and run it to collect the NTLMs of the local users on the target box. And as you can see, the hashes of the top 3 built-in accounts are the same, which indicates they are disabled. There's also the Meterpreter module Kiwi, which basically loads Mimikatz into that Meterpreter session. And to dump the NTML hashes, we'll use the LSA dump SAM function. And when it's complete, here we see Ivory's hash like before. Then here in the demo target, we can also dump the SAM and the system registry hives. We can do this manually and then move offline to crack. We can use PyPyCats, which is a Python version of Mimikatz. This can be installed on Kali. And using the registry function, feeding it the saved system and the SAM hives will produce the NTLM hashes. CME also has a feature to dump the registry, providing the attacker the NTLM hashes remotely. And again, as long as you have those proper credentials. Now we can just paste the NTLM hash in a new file, formatted correctly. And CME outputs the hash in the format for John the Ripper. And then using John, providing it with the custom word list, will show the password like so. Also for Hashcat, you can just paste the NT section of the NTLM hash. Then use Hashcat mode 1000 and just feed it the hash file and password list. Another option is to dump the memory of LSASS, which stores encrypted, or on older versions, unencrypted passwords of users who are logged in or have their credentials in memory for any other reason. Dumping LSASS can provide potential NTLM hashes, service accounts, or domain users. LSASS can be dumped in a variety of ways. One is to dump and parse directly through Mimikatz on target, as long as AV is disabled or really outdated. Once we have elevated ourselves to system, we can run the logon passwords function. If you have RDP access, you can also dump LSASS directly through Task Manager. Just find that LSASS process, right-click, and select Create Dump File. And then you can move that offline for further analysis. Another method is to use the sysinternals app procdump. And this will just create a dump file of your specified process, which can be somewhat large for LSASS. From there, we can move offline and then analyze with PyPyCats. Next is MS Cache. We can collect directly from Mimikatz on target with the LSA dump cache function. And here both domain users Wang and Cram that have logged in. And also from before, here's secrets dump, which obviously here can be used to collect MS Cache as well as NTLM. Also the cache dump Metasploit post module can be used to collect MS Cache. And as for cracking, you can paste the results directly into a file and just feed it to John along with a password list. And here this hash has already been cracked, so we just need to use the show command to display the results. DCsync is a function in Mimikatz to dump password hashes directly from the Active Directory domain controller using the protocol of MSDRSR, otherwise known as Microsoft Directory Replication Service Remote Protocol. The DC stores domain users' hashes in NTLM format, which you can dump with DCsync as long as you have the proper credentials. This basically allows you to collect any AD user's password hash and subsequently crack offline. And to clear up any confusion of NTLM versus MS cache, the domain controller stores domain users' password hashes in NTLM format. So these NTLM hashes are then used in various authentication processes, from the Windows domain join host to the domain controller, including that authentication process of logging into a domain joined host. So once that user logs in, their password will be stored in that hash format of MS cache, on that domain joined host, whatever they logged into. Now, in order to collect NTLM hashes from the DC via DCsync, you'll need user credentials with proper permissions to do so. The required permissions are known as DS replication get changes and DS replication get changes all. And by default, enterprise admins, domain admins, and a few local users to the DC, including that built-in DC administrator, have permissions to DCsync. Through the lifetime of an AD environment, misconfigurations happen, which could allow a user or group object to have effective permissions to run DCsync outside of the default users. If RSAT is installed on a target machine, you can import the Active Directory PowerShell module to run domain-wide search for objects with the proper permissions using the permissions GUID. And in this specific domain, on the kinetic range, this one doesn't have any non-default users that can DCsync. And here in this example, we are logged in as Zonia, which is part of the domain admins group. We can run DCsync directly on target with Mimikatz, providing the domain, which is 0.arc.corp, and then with the all flag to dump all users' password hashes, and then the CSV to output in CSV format. We can also run DCsync to target a specific user with that user argument. This may be a better option in larger AD environments and especially less noisy versus requesting all users. Pass the hash technique has been around for a long time and can still be useful today. Pass the hash can be used to gain access to targets with just the hash password and not the actual clear text password itself. You're doing this by abusing the NTLM authentication process. As previously discussed, domain users' credentials are stored on non-domain controllers as MS cache, not NTLM. So a few methods to collect a domain user's NTLM hash would be to DCsync or dump via LSAS if a domain user was logged in. Since DCsync requires privilege level access, such as having domain admin, dumping LSAS may be a more realistic option. And again, referencing back to local account token filter policy, if you collect an NTLM hash of a local non-RID 500 user, that user will need to be in the administrators group, have the same password, and have that specific registry key enabled. Otherwise, if you collected the RID 500 built-in administrators NTLM hash, you could try your luck on other Windows targets to, 1, see if the built-in admin is enabled, and 2, has the same password, hence the same NTLM hash. Referencing back to our collected NTLM hash of local user Ivory off a target Polar, we can pass the hash onto Area 72. And if you're following along, there are a few hints on Polar that Ivory can access Area 72 with the same credentials. And now that we verified with CME, we can use Impacket's PSExec to get a semi-interactive shell by providing just the hash with the hashes option versus the clear text password, which is unknown. Going back to domain user Zonia and dumping LSAS with Mimikatz, Here we can use the logon passwords function like before, except in this case, Zonia is actually logged in directly, interactively, which is not seen in this video. Even though we have a SSH session and know the user's password, this is just showing how we can collect NTLM hashes off of logged in domain users versus just their stored passwords in MS cache. We can then do the same with domain users. Once their NTLM hash is collected, as long as they have local admin privileges on the target host, which we know Zonia is domain admin. Now, hopefully to clear things up, the target area 72, which we pass the hash with Ivory, has the local account token filter policy enabled, flip to 1, which allows us to execute those remote commands, those remote operations, as a non-RID 500 administrator. Then checking the other target, femme fatale, which we pass the hash as a domain user, the domain admin, which has local admin privileges. We see the key is flipped to 0. And reiterating, this key did not originally exist by default, but was just added and set to 0 to better illustrate this technique. Data Protection API, or DPAPI, is a built-in Windows encryption mechanism used to securely store various credentials and keys. Common ones are saved website credentials in Chrome, saved RDP session credentials, Wi-Fi keys, and other third-party credentials. Collecting these stored creds may lead the attacker to gain access to other services or targets through accessing them directly or through password reuse. Even if you have domain admin, exploiting DPAPI may be useful for further pivoting opportunities. DPAPI uses a few Win32 API functions to run through the encryption and decryption process. One is the crypt protect data function, which is used to encrypt the data, and 2 is crypt unprotect data, which is used to decrypt the data. These functions are programmatically implemented in whatever software wants to utilize DPAPI for Windows systems. To collect DPAPI creds, there are a few tools available, including Mimikatz, Don PAPI or Don PAPI, and SharpDump. The decryption process uses either a user's master key or the domain backup key. The master keys can be deciphered with the specific user's password, usually automatically with Mimikatz or other tools, as long as you're logged in and running Mimikatz as that user. Otherwise, if you're local admin, you can collect other users' master keys on that specific target. As for the domain backup key, you'll need to request this directly from the DC. Mimikatz or Sharp DPAPI has this function built in. But you will need privilege level access, such as domain admin, to retrieve this key. One of the easiest methods to abuse DPAPI is the tool Don PAPI. This can be run remotely from Kali and automates pretty much everything, collecting and decrypting any DPAPI protected files it can. For a default run, just provide the username at target along with the valid password. You can also provide the hash, but it can be a little finicky, so in this example, just using the password. Here, Ivory is a local user who has local admin privileges, and when it's complete, we can see the saved generic credentials of Andros, along with the full Chrome credentials. We can also run with Mimikatz on target, and here we see the login data file within the user's Chrome directory, and this is what Mimikatz and other tools will target for decrypting Chrome saved credentials. And then in Mimikatz, if we're running as that user, we can just throw the unprotect flag at the end, and it will show the credentials in clear text. And make sure you use the DPAPI module Chrome option, providing it the file /unprotect. In this other example, we'll psexec as Ivory with their hash. And with psexec here, we're running as system, not Ivory. So in order to collect those master keys, we'll need to manually find them. Using Mimikatz again, we are system, so we have local admin privileges, so we can run the module and it will provide the master key of Ivory. Once that master key is found, we can feed that directly to Mimikatz DPAPI module along with the Chrome login data file path. And here again, like before, we can see those Chrome credentials in plain text. And besides Chrome, here are other few options within the Mimikatz DPAPI module. Next up is pass the key, otherwise known as overpass the hash, along with pass the ticket. Pass the key involves requesting and collecting a Kerberos ticket from the KDC with a domain user's NTLM hash. And again, here the KDC is the domain controller. This is similar to pass the hash, but here we're providing the hash to get a ticket. And then with this ticket, we can then use the pass the ticket method to further move laterally. Now, pass the ticket is used to authenticate and access other domain services by just providing a Kerberos ticket. Tickets can be collected primarily by dumping LSAS or by the pass the key technique. If a domain user is logged into a Windows host, their ticket, along with their NTLM hash, will likely be in LSAS memory. You can then save this ticket, which will have an expiration date, and authenticate further throughout the domain. Pass the ticket method is useful because Windows services and targets within a domain may only allow Kerberos authentication, which means passing the hash or authenticating with domain users NTLM hash may not suffice. You'll need a ticket to successfully authenticate. Starting off, we can use Mimikatz on a target to collect the NTLM hash of a domain user case. And we're dumping the logon passwords. We're dumping LSAS to collect this NTLM hash. From here, we can use Rubius on target to request and collect a ticket from the KDC by just providing the hash in the RC4 option. And here using klist, we can see that ticket has been cached. We can then use psexec to pass the ticket and remotely spawn a shell on Viper Warhawk, which shows is successful and running under case since we didn't provide the S flag to run as system. And note, if case didn't have local admin privileges, psexec would fail here. Next, we can use impact as get tgt script to remotely request and collect a ticket from the KDC just by providing the hash and user case. And when you're working with Kerberos remotely from a non-domain joined machine, things can be finicky. And here, for instance, the clocks are out of sync. So what you need to do is use NTP date to point to the domain controller, and that will sync our times since Kerberos is dependent on time syncs. And we can try again, which saves the ticket as a file in our current directory. To work with Linux, we need to set the environmental variable of Kerberos CC name. And we're going to point that to the file getTGT script saved. And we can see using klist on Linux here that it is in our ticket cache. From here we can use impegets psexec with the k flag to use Kerberos, setting the ticket as the Ccache file in our environmental variable, along with the DCIP and the no pass to not prompt for password. And out here, make sure to use the full Windows domain. Like in this example, it's kinetic.corp and not kinetic. If you don't include that full domain, this will cause errors with the ticket and further authentication. You can also use a combo of Linux and Windows by utilizing impegets ticket converter script. Ccache tickets are for Linux and Kirby tickets are for Windows. And using ticket converter, you can convert in either direction. And here we're doing Linux to Windows. And then we'll be using this converted ticket with Rubius, so we'll need to encode the Kirby file as base64, and then removing any new lines. That way we can just paste directly into Rubius. From here we can see it is stored in klist, and pass the ticket again using psexec on the Windows target. To collect tickets without the NTLM hash or password of a domain user, we can use mimikatz to dump all in-memory Kerberos tickets, and then export option, which will save them as Kirby files to that local directory. You can then use mimikatz to store a dump ticket in our Kerberos ticket cache by feeding it a Kirby file. While in mimikatz, you can also list the cached tickets. Otherwise, you can exit and run klist, and here we can see case has been added to the ticket cache. And if you'd like to remove all cached Kerberos tickets, you can use the mimikatz Kerberos purge option. Rubius also has the ability to dump in-memory tickets. Here it dumps them as base64 blobs, which we can copy and paste onto our Linux machine to do, as before, remove all new line characters. Then back to Rubius, we can use PTT and paste the ticket, base64 encoded, no new lines, and it will store them, as we can see here in klist. And then we could try again using psexec on Viper Warhawk. A golden ticket attack is when you collect the hash of the domain's KRB TGT user. This then allows you to craft any ticket of any user on that domain, hence the name golden ticket. You essentially have a ticket, or have the ability to craft any ticket that allows access to pretty much anything on the domain. So the domain's KRB users NTLM hash, you can impersonate any user within that domain by forging a Kerberos ticket for that user. This allows you to access domain services and applications that require Kerberos authentication for specific users or groups. Also, a golden ticket will allow you to escalate from a child domain to a parent domain, or domain admin to enterprise admin. When creating a domain or adding a domain, the KRB TGT user is automatically created, along with the password is auto-generated, which is a very strong password, and generally wouldn't be a realistic method to try to crack this hash. So in order to collect the KRB TGT's hash, you'll need DCsync rights or full access to the AD database. In other words, to craft a golden ticket, you'll need domain admin or similar effective privileges. Coming up in the full-phased pen testing section, we'll run through the technical side of what tools to use, the commands, and the whole golden ticket attack process. Starting off, we're going to target dev super, which will then lead us to Moondust. Quick synopsis of the process. We'll go through SMB and file enumeration, finding and massaging a functioning exploit DB proof of concept, along with some AV evasion. Then we'll extract sticky notes, and then pivot via password reuse, collecting and dropping files with FTP, and then privesking from PowerShell history, and then with that PS remoting on with privileged access. First off, we'll run an aggressive Nmap scan covering most of the TCP ports. When complete, we see sharing seems to be enabled with SMB and RPC ports open, 135, 139, and 445, along with this 1978 port, which seems unusual. And we'll start by targeting SMB using Impact's SMB client. And we'll provide the username and password we collected from a prior section to try to access SMB. And this user SYN was in the Kerberoasting section. And then listing the available shares, we'll get on the corporate share. And navigating around this share, we'll go into IT guides, and then we see a note on security text file. Then we'll read this. So due to a number of user complaints, IT has reduced security restrictions on this share. From now on, Windows Defender won't auto-remove your apps. You're welcome. So we'll note this for later, and then from here we'll just start downloading, collecting files from the share for later recon or intel. And here we have the files downloaded, skimming through, again, that note on security. And then we'll go through a few sales brochures, and we'll note websites and potential usernames or any other useful information. Now we'll start looking into port 1978 on Google. And it seems there are a few proof of concepts related to looks like Wi-Fi mouse or remote mouse, which runs on port 1978. Now we'll search exploit DB for Wi-Fi mouse. We see a few more show up. We'll click one that's verified. And we'll use searchploit since the POC will be on our local Kali system. We'll search it and then we'll make a local working copy. And skimming over the POC at the bottom is the code execution part. This part just basically downloads a payload and then puts it in the temp directory. So we're going to replace that with our own, since we can drop a payload on that share and Defender shouldn't pick it up. So we'll just do the share path escaping slashes div super corporate, and then we'll create a payload interpreter reverse shell, and then we'll drop it on the share, and then this POC should essentially execute that. Then since we're just going to execute it directly, no need for that line. We'll comment that out. Next, we'll create the payload with MSF Venom set to port 4333, and then we'll spin up our listener and Metasploit. Now once we have our payload created and our multi-handler listening, we'll SMB back onto the corporate share and then drop our payload. And then once we drop our payload on the share, we'll verify it didn't get hit by Defender or anything, and it shows it does exist. So now we'll execute our proof of concept to execute the payload on the share, and we'll provide it our essentials. We don't really need these because we're just executing it. And then after execution, it looks like we are not getting a callback from the shell. And then showing the contents of the share, it looks like the exploit is still on disk, and we'll run it again. And still no luck. And listing out that directory again, it looks like the payload has disappeared, which indicates Defender is catching it and putting it in quarantine or deleting it. So now the plan of attack will be to point directly to the local file system wherever that payload is located instead of the actual share. So we're going to output net share to the share, corporate share, to a.text, and we'll actually, this command should give us the full local file path of that share. That way we're not doing // dev super corporate payload will actually be doing, drive letter, wherever it's located. And saving that and executing the proof of concept, we'll jump back on the SMB share and then check to see if a.text exists. It looks like it does, so we'll read the output of that. It looks like the corporate share is in C/corporate. So our plan will be to just replace that share path of dev super. We'll just do C corporate and then our payload name. The idea behind this is Defender may have an exclusion, not to the actual share, but to the local file path. So it might be exclude everything in C/corporate versus the actual share name, which is why we're getting caught by Defender. So updating that payload and moving the payload back onto the share since it was removed by Defender originally. And we'll rerun our proof of concept. It looks like our reverse shell was successful. Looks like our interpreter session, we are running under domain user Kinji, and we'll drop into a shell to do some basic local enumeration. Checking out the administrators group, we see a local user of Pris and the built-in administrator along with the domain admins. So we see users, we see a few Jane, Kinji, who we are, and then there's Pris. We'll check out our user's desktop, and we see a few things of interest, including a Spire talent memo, along with a sticky notes shortcut. So now we'll download this Spire talent memo. And here reading the memo, a few things of interest is a project called CyberDoom, and then it looks like the CEO name of Walter. So next, our plan will be to extract sticky notes, and we'll use the sticky notes extract.exe. This is on the Kinetic lab in the software web server. It's part of the Sharp collection. And the reason we're going this route is we saw a .lnk file to sticky notes, which a .lnk file is a shortcut. So we'll use Meterpreter to upload this exe, and we'll put it in Kinji's folder. Once uploaded, we'll drop back into our shell. And then we'll execute it. Looks like there's an error with execution. And remembering the documents back on the corporate share, there was a document on how to migrate sticky notes. So we'll check that out. Reading that, it says, depending on what version you have, you may need to download the 3 SQLite files. Since there's a newer version running SQLite format 3. So now our plan will be to manually download those files and then view them locally on Kali. And we see those 3 files do exist. So now we'll use Meterpreter to download those files. And once those files are downloaded, we can open the SQLite database in the database browser on Kali. And just poking around, we can see there is text saying that you can use a password for PRIS to access other systems. And without the database browser, you can try to read the SHM file or the WAL file to see the contents. And we'll save this password in order to move on to the next part. Now with the PRIS password, which is a local admin, we'll use secrets dump to collect the SAM database, hashes, DPAPI, and any domain cached credentials. So once complete, we see the output, clear text, password of Kinji, and then we see a few domain cache credentials, and then nothing of interest to the local user since we have PRIS. So what we'll do is copy paste those MS cache hashes into a text file and then run John against them. And note in the kinetic range, any domain cached credentials found, the highest password they can have if they're necessary to move on is the John password list. So if they're not found in here, they're really not necessary to kind of move on to get through the lab. This is to save the user or the attacker time and resources. So once John's complete, it looks like none of those hashes were cracked using the John password list. So we'll move on from here. So now that we have local admin credentials, we'll use SMB client again to access the C$ share. And again, if sharing is enabled, SMB is enabled. If you have local admin privileges, you can access this share remotely. And now looking at user PRIS, their desktop, we see a few files or a few images. So we'll get those, and then we'll note that it's Mundi, which is a hint to access from here to kind of pivot onto the target Moondust. And then we'll move those images from the in-packet directory to our working kinetic directory and view those just to see if there's anything of interest. And first, against Moondust, we'll run a nmap scan. TAC SC runs a default set of nmap scripts. And ping is disabled, it looks like, so we'll do TACPN. And here when it's done, it looks like only FTP and HTTP are open. And if we open a web browser in Burp and we go to Moondust port 80, it shows just a default IIS web page. And just checking with Nmap to see if anonymous login is enabled on Moondust FTP server. Looks like it is not. So we'll quick check to see if Pris has access using the password we found on DevSuper. And it looks like those credentials failed. Now going back to our Bloodhound instance, we'll search nodes FTP. And we're seeing a FTP users group along with ftp.pris. But first we'll check the FTP users group. And from here we can narrow down the users that are part of this group. And we see domain user Wang along with ftp.pris. So now we'll use ftp.pris going into Moondust, and we'll try to see if password reuse works, which looks like it does. And then navigating around directories and checking out files, we see a update.bat file, which we'll download. It looks like this script is a site update script, which just looks like it creates backup files and deletes old files. And then going to project tag moond.html. Looks like just the main project site. Gives you a description of the project Moondust. And then looking at the photo gallery, there's web config, looks like it's a 403, and then a few images, but nothing else of interest at the moment. So now the plan of attack will be to update or replace this update.bat script with our own. So first we want to see if we can write to this FTP directory or subdirectories. And it looks like we can write to the web root. So now our plan will be to create a interpreter exe, drop it via FTP in the web directory. We'll drop it in scripts. Then we'll replace the update.bat script with our own, which would just point to the newly dropped interpreter payload. That way, based on the script comment, the scheduled task will essentially execute our interpreter exe. Also here in this case, it's probably best practice to drop a web shell versus dropping a reverse shell, opening a whole nother socket. We're going this route because there weren't any server-side language handlers like ASP, ASPX, PHP. Of course, we didn't show this in the video, but that's why we're rolling with a reverse shell versus web shell. And next we'll FTP back on as Pris, and then we're going to upload this reverse shell, so we have to switch to binary instead of ASCII through FTP. Since exe is a binary file. If we left this as ASCII and didn't change it to binary, the upload would basically mangle the exe and wouldn't be executable. And we'll use the put command to upload our payload, and we're going to be putting it in the scripts directory, and looks like it uploaded successfully. So now we'll go back to that update.bat, and we'll just delete the contents and replace it with just our payload. So essentially this scheduled task that runs every 5 minutes, as per the comments, should just execute the local file 33.2.exe that we just uploaded. So we'll delete the update.bat script. But first, before we upload the new one, we'll create our listener in Metasploit. And now that our listener is running, we'll go back to FTP and then we'll make sure to switch back to ASCII since we're just uploading a batch script, kind of like a text file, so it will need to be in ASCII. Otherwise, it will be mangled if it's still in binary. So now we update that and we'll wait. And after some time, we notice the listener never got a callback. And our payload is still in the directory, so the idea will be to get the full working directory, the full web root, the full path of where FTP is bringing us. And by default, the IIS web root is C inetpub www root. So we're just going to make sure that that's the full path. That way we can provide the update.bat. We'll provide that script, just the full path, kind of like in DevSuper. We want to provide that script, the full path to the exe, since it may be executing out of system 32 versus executing out of our web root. Like it may be looking for 332.exe in system 32, but it cannot find it. So we just got to provide the script with the full path to our payload. So now after giving it some time, we can see c.text is in the web root. So now we're sure that the FTP directory, which is also the IIS web root, is in the path we provided, which is the default IIS web root, inetpub www root. So now the plan will be to just put our payload that we uploaded. We'll just give it the full path, and then that way when we drop it, it should just execute it. Now once uploaded, we'll give it a little bit and see if we get a callback. Here looks like we did get a successful Meterpreter session, and we're running under a local user duster. We'll run some commands to get situational awareness, and then eventually we'll be brought to Duster's desktop, and we see a PowerShell shortcut along with a PDF about basics of PowerShell scripting. So now that we see the PowerShell shortcut in this PDF, the plan of attack will be to check Duster's PowerShell command history. That way we can see if there's any useful ways to either pivot or escalate our privileges. And we'll go to Hacktricks. They have a really good Windows privilege escalation page, which sort of mimics WinPs and all the commands WinPs runs through, and provide some context. So we'll go to the PowerShell section, and then we'll just look at this command, copy, customize it to Duster, and then we'll see what it brings back. It looks like there are credentials mistakenly in the history. So we have administrator with a password of kibble832. We'll run netstat because we see the evidence of PowerShell, so we're going to check if PowerShell remoting or WinRM is enabled. It looks like it is, port 59A5. And this did not pop on our Nmap scan because we didn't do a full port scan. We just did the TAC SC, which runs through a basic set of Nmap scripts, which obviously didn't include the 5985 port. So now that we see WinRM is enabled, we'll use evil WinRM on Kali with the found credentials of administrator and kibble832. And it looks like we were able to log on with those credentials. And a quick note for kinetic range. Most of the files, in order to pivot or move on, kind of the juicy files, you're going to find in users desktop. This is again to save users time versus putting them in who knows where, different subdirectories, hidden subdirectories of other subdirectories. Here in the administrator's desktop, we see a file called ASAP along with a shortcut LNK file to Sublime Text Editor. And then showing the contents of ASAP, we have Rick wants Vindicators patched and updated, set to log in with groups cred since my user doesn't have the necessary permissions. Freaking permissions, can't do anything around this place. So we have a user group, password acidvat9000, and then we have a target system. So from here we could pivot on to Vindicate using group and acidvat9000. We won't go through that process in this course, and we'll leave that up to you if you'd like to continue that on your own in the kinetic range. This scenario will be initially exploiting femme fatale, which is part of the 0.arc.corp domain, and then pivot onto that DC of 0. And then from there, we'll further pivot onto the parent or the root domain controller of arc. So 0 is the child domain of arc. A synopsis of this full scenario will cover exploiting a .NET-based web application, cracking domain cache credentials. We'll reference a previous Bloodhound attack path to gain domain admin, and then from there we'll craft a golden ticket to escalate from the child domain to the parent domain, or escalating domain admin to enterprise admin. From a initial Nmap scan tech SC against femme fatale, we see port 80 HTTP open along with SMB and sharing is enabled. And first we'll target HTTP using WhatWeb in order to quickly get some intel on the hosted web service. And here it looks like it's running .NET Nuke, which is a content management system based on .NET. Now we'll check search exploit, and we see a few .NET Nuke exploits. We'll target the Metasploit one listed here. It's the cookie deserialization vulnerability. So showing this module's info, the module exploits a deserialization vulnerability in .NET Nuke. Vulnerable versions store profile information for users in the DNN personalization cookie as XML. This cookie is processed insecurely by the application whenever it attempts to load the user's profile. And loading a user's profile can be done simply by triggering a 404 with the exploit set as the cookie, as long as the server hosts the built-in custom .NET Nuke 404 page. First, we want to make sure this version is vulnerable. And here we see a CVE date of 2017. And this module does have a dry run option, which we could set. But first, we're going to do some initial investigation to see if this version is vulnerable prior to just running the Metasploit module. So we can check out the source code on the homepage for potential clues. And here we see a 2017 date. Otherwise, one method is to use curl against the app's favicon link, which sometimes will provide a date of last modified. Like here showing February 2017. This could indicate that the actual .NET Nuke version was the version released in February 2017. And checking back at the exploit, we have a disclosure date of July 2017. So with this bit of info, we can assume the running version is vulnerable since it was released prior to the vulnerability disclosure date. So now we'll set up all our Metasploit options, and then we'll run it. And showing here, we get a successful Meterpreter shell. And we'll run get system to see if we can automatically escalate our privileges, which we get with the vulnerable print spooler service. Now we'll drop into a shell and check all the user accounts. And here we see quite a few. So now our plan will be to dump the MS cache and see if we can crack offline. In order to dump the domain cache credentials, or MS cache, we'll use the cache dump post exploit module in interpreter, or in Metasploit, and we'll just set the session and execute. Once dumped, we'll paste it into a text file and crack with John, using the default John password list and setting the format to MS cache. And here we already have the hashes, so we'll just use the show command. And it looks like we were able to get 5 users, one of which includes Freya. And recalling back to the Bloodhound section, we'll search the shortest path from Freya to the domain controller. And this path we briefly covered, which shows Freya is in a group that has effective permissions of a domain admin. So from here we'll use SMP client to poke around the DC0 domain controller. And going to the administrator's desktop, there is a note which reads, "Note to self, moving stuff to the root domain DC_arc desktop, aka arc.corp." Now back with SMP client, we can quick test to see if we can access the admin shares on DC_arc. And we'll use Freya's creds, and it shows we do not have access. So now in order to gain access to the root domain, or DC_arc, we'll escalate our privileges from domain admin on this child domain to enterprise admin, which will allow us full access to the entire domain tree. In order to escalate our privileges to enterprise admin, we'll use a golden ticket attack. So as long as you have a domain admin on a child domain, you can craft a ticket to escalate your privileges to enterprise admin. In our scenario, we can craft a golden ticket a few different ways, one of which is Impact's raise child script. This can be pretty unreliable if you're not on the same subnet, which we aren't since we're VPN'd in. If you get it working, it's a great method which automates the entire process from escalating from a child domain to its parent domain. And just to illustrate, we'll run it anyway and use the TACW to output the golden ticket to a file, and then provide the fully qualified domain name of the child domain along with the domain admin user's credentials. Also not shown, make sure to update your etc resolve config file to point your name server or your DNS to the target domain controller. And running it, we also have another terminal open which just syncs our time, our Kali time, with the domain controllers. And Kali wanted to sync back to local time, so this is just a quick, crude workaround to constantly sync times while that script completes. And since Kerberos is dependent on times to be in sync, the script will fail if your attacking machine is off from the domain controller by too much. So this is kind of why we're just spanning that ntpdate command to just constantly sync with the domain controller so this script can complete. If the times are off, the script will fail. And once complete, you can import or export your ticket accordingly. Another option that may be considered less OPSEC secure, but is more reliable in our case, is to drop Mimikatz on a domain joined Windows target and then just craft that ticket from there. And first, since Mimikatz doesn't automate the process like the Impact script, we'll need a few prerequisites, and these include the domain SID of the child domain, the domain SID of the ARC Enterprise admin, and the KRB TGT NTLM hash of the child domain. And again, the child domain is 0 and the parent domain is arc. And we can collect these prerequisite SIDs with impactget's lookup SID script. And first the domain SID from the 0 domain. Then the domain SID from arc. The enterprise admin SID is the domain SID plus a attack 519. So we can just grep the domain SID of arc and just add 519 to complete the SID for the EA. Now to get the KRB-TGT's hash on the 0 domain, we can use secrets dump against DC0, which will dump the NTLM hashes of all users, including that KRB-TGT account. So now that we have all the prereqs, we'll set up a remote access to target femme fatale in order to run Mimikatz or craft a golden ticket from there. And not shown here, but we discover WinRM is enabled on target femme fatale. So we'll utilize Evo WinRM from Kali to gain credentialed remote access. But running Mimikatz can be tricky via Evo WinRM, so we'll need a better option for remote access. And in this scenario, we'll keep it command line oriented and we'll install SSH on target. And worth noting, if we were on a Windows attacking machine, not Kali, we could utilize WinRM, PS remoting, and successfully use Mimikatz through that method. And since we're on Kali, however, we're going to go another route since it's a more stable option than WinRM, or using Evo WinRM. So first we'll use PowerShell to get the Windows Open SSH zip from our Kali machine. And then we'll also get psexec and Mimikatz in prep for our full domain escalation. To unzip the ssh.zip file, we can check if 7-zip is installed, which has a command line ability to extract zip files. And extracting, we use the X option and provided the full path to the zip file. With the Windows Open SSH package, there's an install script, which makes the process quick and easy. And once installation is complete, we'll manually start the two services. And then we'll use netstat to check if SSH is running by verifying port 22 is listening. Now from here we can SSH in and start our process. With Mimikatz we'll use the Kerberos Golden module, and then providing it all the necessary flags, setting the user to Freya, providing that child domain along with its domain SID, and then the KRB-TGT's hash, along with the parent domain's enterprise admin SID, the TAC 519. And after we execute it, we can quick check to see if we can directory list $C on DCArc, which we can. And then we can also psexec onto DCArc for further investigation. And here we see a few files of interest on the administrator's desktop. And we can download these files by backing out of psexec and just use the copy command, providing that full network path. And then once downloaded to FemFatal, we can download via secure copy, since SSH is now enabled on FemFatal. So we can SCP from our Kali machine to download those files we collected. And then finally, we can analyze the collected files, and we'll note a few passwords and usernames we can save for later on. In this example, we'll be initially exploiting broadcast, and then we'll be pivoting on to Exodus. Topics covered include discovering a public code execution exploit in EDB, and then while bypassing Defender, obtaining and cracking MS cache to identify other targets in order to pivot onto using crack map exec, and then discovering an accessible network share with collected credentials, and then crafting a malicious Word doc to trigger the Felina exploit for remote code execution. First, running an nmap scan shows that sharing is enabled along with a few other unique ports, and some of these shown here provide an SSL cert with a common name of FreeSwitch. So knowing this FreeSwitch, we're going to Google FreeSwitch exploit, and as you can see, it brings up a code execution EDB entry. Now checking it out, it seems to match our target, showing port 8021, and looks like it is Windows based with the NT system in the comments. So we use search exploit to locate and make a working copy of this POC on our Kali system. And looking at the proof of concept, the exploit looks like it just needs the target and the command you'd like to execute. So we'll get the IP just to be safe to avoid any DNS issues. And then we'll execute a few basic commands. And showing it seems it doesn't bring back every command output, but it seems to have an accurate content length response size. So we can kind of assume that our commands are executing server side. So from here, knowing we can execute code on the target system, we'll create ourselves a user and try to give ourselves local admin rights. That way we can use SMB client to poke around the system more efficiently. And here shown we get an access denied when connecting with SMB client. And as stated from a previous module, this is likely due to local account token filter policy being non-existent, which will affect remote access as a non-domain local administrator who is also not the RID 500 default administrator. And in our example, we added a local admin who is not, is non-domain joined, which of course wasn't a default built-in admin. So without this registry key will have to be enabled in order to conduct remote access with a high integrity token. So we use the FreeSwitch exploit again to remotely add that registry key with the regadd command. And then we'll create a new SMB client session. Which allows us access. And then we'll poke around a bit, noticing quite a few cached users in the C users directory. We can also try to psexec to get a semi-interactive shell. But shown here, it seems to hang. And this can indicate that psexec, or this instance of psexec with impacket, is being caught by Defender and quarantined. So next, in order to get a more stable shell, get more stable access, we're going to use FreeSwitch to enable PS remoting, and that way we can get on without triggering a Defender now that we have valid credentials. And checking Defender's status, we see real-time protection is enabled, so we'll try to disable it. And here it shows it doesn't seem to work. And this is likely due to an updated version of Defender with tamper protection enabled. So from here, we likely can't drop Mimikatz because from our access, we can't disable real-time protection, so it'll be caught. So another way, we can just quick try to see if secret dump will work, and that way we can just dump all those cached credentials remotely, since we did notice all those users. And once complete, we see local user punks with the plain text password, along with multiple MS cached credentials. Now we'll copy these to a text file and then crack with John. And shown here, we get a few valid passwords. Next, we can use crackmap.exec to see if any of these users have access to other services within the kinetic range. And to save time, the kinetic targets text file shown here is just broadcast and Exodus, since it's sort of the intended path we're working with. And we'll use a list of users and passwords with the no brute force flag. And this is just to indicate to use each list as a one-to-one username and password. And we see user Yardi has SMB access to Exodus, which will be our next target. We'll use SMB client to check out the shares and try to connect to $. But shown here, we fail. Then we'll try the workflow share. And we see a few files of interest, which we'll download. And checking them out, we see a OneNote file, which we can try to open in gedit, which will be sort of mangled. And we can read a few things, which mentions to update MS Office since it's outdated. And then we see a software products list, which includes Microsoft Office products, and it says, looks like it's Office 2013. So definitely an outdated version of Office is running on Exodus. And then the README file says to place workflow related Word docs in the docs folder with the name update.ldap. docx, and then this user writing this will check them ASAP. So with his knowledge of an outdated MS Office version and knowing that a user likely on Exodus will check any Word docs we drop on this share as long as it's named update, we can try the Felina exploit, which will get us remote code execution. And checking out the GitHub POC, we see the script takes a few arguments, including the full UNC path to the evil binary, in which that docx will execute for us. So now our plan of attack will be to create an exe interpreter reverse shell payload with a listener, and then drop that interpreter payload on the workflow share, and then we'll build that Felina exploit with this GitHub POC, which will generate a evil docx payload. That will drop that on the share. So once that user opens the docx, it should essentially in turn execute our dropped interpreter exe on that share as well. And now we'll create our payload with MSF Venom, and then set up our listener in Metasploit. And then we'll drop our interpreter payload with SMB client. Now we'll run the Felina exploit, which was cloned off screen. And then in the command, we'll provide the UNC path to the interpreter exe we just dropped. And note we're assuming workflow share or the directory is in the C root. Also, we'll provide the file type of docx and then the HTTP host and URL of our Kali IP, which this exploit needs to execute. As shown, it listens on port 80, hosting a malicious HTML page, and also produces a docx called clickme. So referencing back to that readme text file, we need to rename the clickme to update. Then we'll jump back on SMB client and upload update.docx to the workflow share in the docs folder, and then we'll wait for a callback. And we get a successful shell onto Exodus as local user Blaster. Now from here, we'll drop into a shell and check out Blaster's user. And noting a text file that includes Blaster's password and a BitLocker password that was removed. And this kind of gives us a hint to look for encrypted drives on Exodus. And going to the C root drive, there's a directory called secure, which has a virtual hard disk file. And the interpreter shell ends up being unstable because that user is probably clicking on the update.docx, which kind of relies on our shell. But we have Blaster's password, so we can check with Nmap to see if any other remote access services are running. And it seems WinRM is open, so we can get a more stable access shell or session by using evil WinRM. Also not shown, there's another target we haven't gone through in this course or in this module, which has a custom range specific tool that supposedly cracks BitLocker. So having this now or obtaining this tool later, we could log in with Blaster's credentials we just found instead of going through that whole exploitation process again. And we'll assume we just have it, and we'll drop it on target, execute it, and try to see if we can access the secure.vhd drive. With WinRM, there's no built-in way on this machine specifically to unlock and view the contents of a drive that is BitLocker encrypted. So our final plan will be to enable RDP, and then RDP in, run the tool, unlock the drive, and collect any contents. So here we're enabling RDP by adding 2 registry keys and adding a firewall rule to allow RDP. And then running netstat, we see port 3389 is open. And we use our desktop on Kali to RDP in and use Blaster's credentials. And once logged in, we can try to mount the secure.vhd, and we confirm it is protected by BitLocker. And now we can use SMB client to quickly upload that BitLocker cracker that, again, hasn't been shown in this module, but is available on the kinetic range on a specific target. So we'll upload that binary to Exodus, and that binary is called bitblaster.exe. Now back on RDP, we can run bitblaster.exe from the command line. And we see it produces a BitLocker password for us. And we can right-click that BitLocker drive and unlock, and finally enter that password in. And when open, we see a few files we can open up, check out. And then we can move back to our SMB client session and just download those straight to our Kali machine for later use. In this scenario, we'll be initially exploiting uplink, which is a dual NICT target, into a closed network, which is part of the Pulse domain. And once uplink is owned, we'll pivot onto the Pulse domain controller. TTPs covered include username enumeration, password spraying, tunneling, and then exploiting the DC with Print Nightmare. So to get onto uplink, we'll first use credentials we harvested from a previous section in order to scan for any useful intel on available network shares within the kinetic domain. So from this point, we can say we've just gotten SYNS creds and are scanning accessible SMB shares in order to gain further domain intel. And now that we're necessarily targeting uplink first here, but right now we're just further gathering information to aid in lateral movement and pivoting. Using CrackMap exec, we'll scan a list of kinetic targets with user SYN's credentials, along with that shares flag. And this is used to quickly identify accessible shares with the provided credentials. Shown here are a few shares, one of which we'll check out as the files share on target agent special. We'll use SMB client to get onto the share and check it out. And we see a few files of interest along with the directory of Pulsar. And going into that, we can see it contains other files of interest, which we'll download to further investigate. First, we see the Pulsar netmap image, and this indicates Uplink has access to the Pulsar Corp, but is likely in a closed network, inaccessible to us. And then we view the Pulsar brochure, and after skimming, it gives us a summary of the Corp without much more to note. Then the Notes for Admins file gives us a useful bit of info showing there's no logout policy on the Pulsar domain, and we'll note this as a potential vector to get onto Uplink. And lastly, opening up the incident report, we'll skim for information and noting names Andros, Hammer and Zombie, and at the bottom the site administrator name of Ed. We'll save these users to a text file for later use. Now, an alternative path could have been taken to access the Uplink share. We'll use enum for Linux to scan Uplink's SMB service. And we see the share is accessible anonymously without credentials. So from here, we can open up Kali's File Explorer and browse directly to Uplink share and view all the necessary contents. And to clarify, the Uplink share has mostly the same documents found on the agent specials share we accessed previously. This way, it's just anonymous and you don't have to have any kinetic domain user credentials. So now our plan will be to scan for open services that allow remote authentication, and then conduct password spraying and brute forcing with those credentials obtained from the incident report. And using Nmap, we see SSH, SMB, and RDP are open. Now we know a few services are running for brute force attacks. We'll split up the 4 users into 2 files with 2 users in each file. So that way we can attack each service with a smaller group of users, and basically the hope is to speed up the process. We'll use the tool spray against SMB, feeding it 1 user list at a high attempt threshold of 4,000. That's because there is no lockout policy, and the John user list I think is like 3,000 passwords. So we'll let that run, and then we'll use Hydra against the SSH service, providing it that other user list. And then we'll use the T8 argument to basically speed up that process. When complete, we see 2 passwords are found with SSH. And checking spray, doesn't seem to be any success yet. So for now, we'll just end it, and then if we need Ed or Andros's passwords, we'll just come back to it. Next, we'll SSH with Hammer's creds and start poking around. And here we see on Zombie's desktop are a few things, including a note. With Andros's domain username and password. Now we'll jump back onto our Kali machine and use SAP to collect the files, and providing it that source file and destination. Reading the Spire memo seems to be the same one we collected from a previous box, so we can disregard. Running NetSat, there seems to be 2 IPs, one of 10.65.390 and the other of 10.65.1090. And as referenced in the net map, the target is a dual NICed machine, with one pointing to an internal closed network and the other pointing to a network here we have access to. Next, we'll log in with domain creds and do some local enumeration, the goal to investigate more into this Pulsar domain. And running system info shows uplink is on server 2012. And join to the pulsar.corp domain, with a DC being hostname DC Pulsar. And also looks like it is dual NICed, like discovered previously. And quickly, we'll verify DC Pulsar is the DNS on that second NIC by pinging it and showing that it is with the IP of 10.90.10.92. We'll head to the CyberTools page and plan to drop SharpView, which is a C# port of PowerView, onto the uplink target. And first we'll download it locally to our Kali machine and then SCP from Kali to target. Running get domain controller, we pull back a bit of info, including the DC's OS version, FQDN, and other info. Then the get net computer will pull back data on each domain join computer, which we see the DC, and then a target name undermine, along with our current target uplink. So now we'll jump on uplink with RDP, which will provide us a more GUI-friendly remote access, especially being on a multi-home target. And checking out the DC's shares, it seems everything is default. And then going on to undermine, there's a shared directory called things to print. And this has the already collected incident report in it. Then in another directory called network tools, and we'll note a few shortcuts and binaries to command line related tools. And noting the things to print folder on undermine, we can also check if the DC is running the print spooler service. This is in order to identify a possible exploit vector of print nightmare. And by doing that, we can just do a directory listing of the spool SS path from a domain join machine. And if it comes back like so, then the target is running the print spooler service. Now, knowing this, along with the OS version being server 2016, we can begin to explore the print nightmare as a exploit option. And then going to this targets page, DC Pulsar does have a few hints available with a GitHub POC link. And going there shows it is the print nightmare exploit, and this one is ported into the Impacket library. So this proof of concept will execute an arbitrary DLL of our choosing, hosted on a domain share that allows anonymous access. And this will all be done on behalf of the domain controller. And not shown here, we already downloaded it per the directions on the GitHub page. The arguments it takes is a valid domain user's credentials, which will use Andros, the DCAPI, and the share path where that DLL payload will be hosted. Now, since the exploit cannot directly reach the domain controller from our Kali machine, we'll need to set up a tunnel and run the POC through proxy chains. And we'll also need to set up a reverse shell as the DLL payload with MSF Venom, and we're going to have it call back to uplink. And we'll listen on uplink with netcat, so we'll also need to drop that netcat binary as well. We'll drop that netcat exe with SCP along with Chisel, which is a robust tunneling tool for both Windows and Linux. And then we'll create our DLL payload, making sure our local host, or this host it will be listening on, is the publicly accessible uplink IP where our netcat binary will be listening. Once the payload is generated, we can use SMB client to drop onto the share. And again, this share already allows anonymous access, which is a prerequisite for the exploit. And now that everything is set, we'll check our proxy chains config and see the SOCKS port is set to 2600. And this is the port where the reverse tunnel will pipe back through. So with Chisel, we use the server argument and our IP along with a port to listen on. And then we're setting that SOCKS5 and reverse argument to create a reverse tunnel once it's established. Once our Chisel server is listening, we'll run the client to connect back and establish that tunnel. On Windows, we use the client argument along with the IP and port of the Chisel server to connect to. And we also add that reverse tunnel argument and its port, which we set in our proxy change config, the 2600. And running that client connects back to our server, establishing our tunnel. So now, to clarify, anything we pipe through port 2600 or how proxy chains is configured on our Kali machine, anything piped through that will get sent through our tunnel and out through uplink as if traffic were coming from uplink and not us on Kali. We'll open up another terminal to set our netcat listener on the port we entered during the MSF Venom payload generation in order to catch the reverse shell once that DLL is executed by the actual exploit. And now the exploit, we use proxy chains and include the domain username and password, the DC IP address, along with that full network share path where our DLL payload is hosted. And running it, we do get an error in packet, which is probably due to it being tunneled. But looking back on the RDP session, we do get a successful reverse shell. And we'll poke around a bit, heading to the administrator's desktop, and note a few text files of interest. And we'll just copy paste those onto uplink and that SMB client download. And which, if your RDP clipboard is working, you can just simply copy paste directly to your Kali machine since they are just text files. So now to sort of review and clarify the tunneling process, we'll quick check netstat and walk through all the connections. On the DC, we see a connection to uplink port 4442, which is that DLL payload we created and our netcat listener. And then on uplink, we see our SSH RDP along with the tunnel connection. And again, our tunnel connection back to our Kali machine was the Chisel server listening on port 5447. And now on Kali, we have the two tunneling ports listening, port 2600 and 5447. And then at the bottom, the one tunnel established linking the uplink Chisel client to us on port 5447. First, thanks for purchasing the Slayer Labs Windows and AD Pentesting course. With this course purchase, you do qualify for free 7-day lab access to the kinetic range. To redeem, just send an email to learn@slayerlabs.com with proof of course purchase, and you'll be provided with a free VPN access kit. This will give you full access to the entire range, that way you can follow along throughout the course. Udemy has strict rules on promotion and external services, even if they are free and complimentary to the course, which is why this can only be mentioned in the bonus section, and it wasn't mentioned on the main course page, the title or the heading. And that being said, if you are just seeing this and have already purchased lab access through normal means, feel free to email us with proof of course purchase, and we'll extend your access by 7 days free of charge. And also be sure to check out our website, other ranges and be on the lookout for any Udemy coupons directly on our website, direct course links, and other discounts. And once again, we do appreciate your purchase. And if you do have any critical course feedback or recommendations, please feel free to email us directly.